At the icy end of the Earth, between the glaciers of the Arctic and the cold ice of the Antarctic, a silent ecological revolution is reshaping the pattern of the ocean world. This once considered eternal and unchanging world of ice and snow. We are currently experiencing unprecedented changes. The extent of Arctic sea ice has shrunk by about 40% in the past 40 years. The sea ice area in Antarctica has also hit a historic low. In this rapidly changing environment, a marine creature dressed in crimson armor and resembling a prehistoric creature, the emperor crab, quietly changing the ecological balance of polar oceans. It is both the coveted red gold in high-end restaurants. The selling price per kilogram can reach up to $200. He is also a worried, perfect invader for marine ecologists. Under its hard shell, hidden is a complex story about human intervention, ecological balance, and global trade. This story begins with a bold experiment during the Cold War era. But it has evolved into a major challenge facing the global marine ecology today. Professor Ragnar Johansen, a marine biologist at Tromsø University in Norway, pointed out that the global spread of king crabs is a typical case of ecological cascade effect. A small intervention, after decades of fermentation, ultimately triggered a global ecological chain reaction. This reaction not only changed the structure of the underwater ecosystem, it has reshaped the food web of polar oceans, affecting multiple trophic levels from microorganisms to whales. Legacy of the Cold War, Soviet ecological experiments. In the 1960s, the atmosphere of the Cold War enveloped the world. At the same time as the intense space race between the United States and the Soviet Union, an unknown ocean race is quietly underway. In 1961, Soviet leader Khrushchev proposed at an internal meeting, "We must demonstrate the superiority of socialism on all fronts, including the depths of the ocean." In this context, a plan codenamed Red Gold was secretly launched at the Soviet Fisheries Research Institute. Dr. Ivan Petrov, the scientific director of this project, wrote in his diary, "We are required to prove that socialist science can transform nature and create wealth." Petrov and his team conducted 18 months of research. Finally, the exploration and simulated stone crab was selected as the transplant object. This crab has a huge body size and high economic value, considered to be able to adapt to the cold environment of the Arctic. Between 1961 and 1969, the Soviet Union conducted a total of 23 large-scale transplant operations. According to decrypted archive data, a total of 1.5 million larvae, 10,000 juvenile crabs, and 2,600 adult crabs were released. These crabs are carefully placed in specially designed transport boxes. Arrived at 12 designated drop points in the Bering Sea by icebreaker ship. Each placement point has undergone strict screening, requiring a water temperature between 2 to 5 degrees Celsius. Water depth of 200 to 500 meters and abundant benthic organisms as a food source. The initial monitoring results are encouraging. The internal report of 1965 showed that The survival rate of transplanted individuals has reached 67%, and some female individuals have started laying eggs. However, the report also mentioned worrying signs. Observing a decrease in the number of local benthic organisms, further monitoring is needed. These warnings did not receive sufficient attention at the time. The turning point occurred in the late 1980s. In 1987, scientists from the Norwegian Institute of Oceanography discovered a sizable population of king crabs in the southern part of the Bering Sea. Monitoring data shows that the king crab is spreading westward at a speed of 50 to 100 kilometers per year. The population doubles every 5 years. What's even more shocking is that these crabs have shown amazing adaptability. Their diet and reproductive habits have undergone significant changes. The biological code of two perfect invaders. The reason why the king crab can become a successful invader is due to its unique biological characteristics. From a taxonomic perspective, the king crab is not a true crab, but belongs to the family crabapple. This evolutionary difference gives them a unique survival advantage. With only 6 legs and a pair of crab claws, they move more efficiently in the deep sea. Their gill cavity structure is unique, allowing them to survive for longer periods of time in unsuitable environments. Adult survey and simulated stone crabs can be regarded as giant invertebrates in the ocean. Scientific research shows that their leg span can reach 1.8 meters and they weigh over 10 kilograms. The dense spikes on the exoskeleton are composed of chitin and calcium carbonate, forming an effective defense system. Experiments conducted by the University of Alaska have shown that the hardness of this exoskeleton is sufficient to withstand the biting force of killer whale teeth. In the Bering Sea, they have almost no natural predators and become true, top predators. Reproductive ability is another key factor for the successful invasion of king crabs. A healthy female crab can carry 500,000 eggs at a time. These eggs will go through 5 planktonic larval stages after hatching and spread hundreds of kilometers away with ocean currents. Research from Tromsø University in Norway shows emperor crab larvae have amazing environmental adaptability and can develop normally in a water temperature range of 2 to 10 degrees Celsius. What is even more worrying is that their sexual maturity age is 1 to 2 years earlier than in their native habitat. But what worries scientists the most is the diet of the king crab. They are typical opportunistic predators, feeding on almost everything from algae and worms to shellfish and fish eggs. Analysis of stomach contents shows that an adult king crab needs to consume 3% to 5% of its body weight in food per day. During the foraging process, they will completely alter the underwater environment. Observation records from the Scripps Institution of Oceanography in the United States show a group of 100 king crabs can clean up 300 square meters of underwater area within 24 hours. Alaska, bloody gold in the Ice Sea. While the Soviet Union was conducting ecological experiments, another story was unfolding along the coast of Alaska. The local king crab population here supports one of the most dangerous and profitable fisheries in the world. The 1970s were the golden age of Alaska's king crab fishing industry. The highest annual catch reached 94,000 tons, valued at over $300 million. Winter in the Bering Sea is a nightmare for fishermen. Meteorological data shows that winter wind speeds in the region often exceed 130 km per hour. The waves can reach up to 12 meters high, and the temperature drops to -20 degrees Celsius. In such an environment, crab catchers must stand on a deck covered in frost. Operate a steel crab cage weighing 300 kilograms. According to data from the U.S. Bureau of Labor Statistics, the occupational mortality rate of Alaskan crab catchers is 50 times higher than that of ordinary workers. Captain Mike Johnson recalled, "In the winter of 1978, we worked continuously for 36 hours. The ice on the deck is as thick as 15 centimeters, and everyone has been frostbitten. But when I see the crab cage filled with crabs coming out of the water, all the pain is worth it." That quarter, his fleet captured 120 tons of red emperor crabs worth over $800,000. However, this prosperity did not last long. In 1983, the population of the red emperor crab suddenly collapsed, and the catch plummeted to less than 10,000 tons. Subsequent research by oceanographers has found that overfishing is only part of the problem. The pressure of climate change and the impact of ocean acidification, and the complexity of the ecosystem itself, together led to this disaster. Long-term monitoring by Alaska Fisheries Science Center shows the rise in seawater temperature leads to a decrease in the survival rate of crab larvae, while also making them more susceptible to parasitic infections. Global spread, ecological crisis from the Arctic to the Antarctic. Just as the Alaska king crab fishery collapsed, Norwegian fishermen began reporting unsettling findings. In 1992, the king crab was first discovered on the northern coast of Norway. Subsequent monitoring data shows that the population of king crabs in the Bering Sea has spread to the Norwegian coast. And the quantity is showing exponential growth. In 2000, the estimated number of king crabs in Norwegian waters had reached 20 million. The Norwegian government's response strategy is quite distinctive. By establishing strict management systems, including fishing quotas, size restrictions, and gender restrictions, Norway has successfully turned the king crab into a multi-billion-dollar industry. Statistics from the Norwegian Institute of Marine Research show that in 2022, the catch of Norwegian king crabs reached 1,200 tons, with a production value exceeding $150 million. However, the most shocking discovery to the scientific community occurred in 2011. A U.S. research team is underwater at a depth of 850 meters off the coast of Antarctica. Discovered a cluster of over 1 million king crabs. This discovery overturns the long-standing assumption that the temperature in the Antarctic waters is too low and unsuitable for the survival of king crabs. Further research reveals that global warming is causing an increase in temperature in the Antarctic waters, created a suitable living environment for the king crab. Continuous monitoring by the Antarctic Marine Living Resources Conservation Commission shows the population of king crabs is advancing towards the inland waters of Antarctica at a speed of 30 kilometers per year. Scientist Sarah Emery warns, Antarctic creatures evolve in isolated environments. They have no ability to deal with such large predators at all. If the king crab continues to spread, it may lead to the collapse of the Antarctic benthic community. The ecological impact caused by the invasion of emperor crabs is like a toppled domino, triggering a chain reaction in polar marine ecosystems. In the Bering Sea, long-term monitoring data shows that since the establishment of the king crab population, the diversity of benthic organisms has decreased by about 50%. Some unique mollusks and starfish species are on the brink of local extinction. More profound impacts emerge at the food web level. Due to the large number of king crabs preying on benthic organisms, the number of fish that feed on these organisms has decreased. According to records from the Norwegian Institute of Marine Research, the population of cod in areas with a high concentration of king crabs has decreased by 30%. This change in turn affects the foraging behavior of seals and whales. Scientists have also observed the impact of king crabs on carbon cycling. The polar seabed is an important carbon sink area, and benthic organisms play a crucial role in carbon sequestration. The foraging activities of the king crab have damaged the seabed sediments, leading to the re-release of sequestered carbon. Preliminary estimates suggest that this may reduce the carbon sequestration capacity of the Arctic seabed by 10% to 15%. The model prediction from the University of Alaska shows, if the king crab continues to spread at its current rate, by 2050, 70% of the Arctic's underwater ecosystems will undergo significant changes. This change not only affects biodiversity, but may also alter the primary productivity of polar oceans. Furthermore, it will affect the global carbon cycle. Economic gains, red gold in the global trade network. The global trade of king crabs is a multi-billion-dollar industry. Its complexity is no less than their ecological stories. In the past 20 years, the landscape of this industry has undergone earth-shattering changes. According to data from the Food and Agriculture Organization of the United Nations, the global trade volume of king crabs has increased from $500 million in 2000 to $2.5 billion in 2022. The changes in trade routes are particularly significant. Traditionally, king crabs are mainly exported from Norway and Russia to high-end markets such as Japan and the United States. Live crabs shipped by air are expensive at the Tsukiji market in Tokyo. The premium king crab once set a record of $500 per kilogram. However, with the increase in the production of Russian king crabs and changes in geopolitical factors, trade routes are starting to reshuffle. According to trade data in 2023, China has become the largest importer of Russian king crabs. According to Chinese customs statistics, over 30,000 tons of live crabs worth approximately $1 billion were imported from Russia this year. The change in this trade pattern is partly due to Western sanctions on Russian seafood products. But it also reflects the growing demand of Chinese consumers for high-end seafood products. The changes in the Chinese market are particularly noteworthy. 5 years ago, emperor crabs were mainly found in 5-star hotels and high-end restaurants. Now it has entered the dining table of the middle class. Shanghai seafood importer Zhang Wei stated, "We have reduced the price of emperor crab from 1,000 yuan per kilogram to 300 yuan by optimizing the supply chain. Market demand shows explosive growth. However, this expansion has also brought new problems. Market analysis shows that nearly 90% of emperor crab importers are in a loss-making state. Excessive competition and price wars have compressed profit margins. And Russia's increasing fishing quotas have further exacerbated market saturation. What is even more worrying is that the problem of illegal fishing and smuggling is becoming increasingly serious. It is estimated that $200 million worth of king crabs enter the market through illegal channels every year." The complex impacts of climate change. Climate change is affecting the distribution and survival of king crabs in complex ways. In the Arctic region, warming seawater and receding sea ice have created new habitats for king crabs. A study by the National Oceanic and Atmospheric Administration of the United States shows that some of the Arctic waters, which were originally too cold, are becoming suitable for the survival of king crabs. Model predictions show that by 2050, the area suitable for the survival of king crabs in the Arctic will expand by 40%. However, the other side of the matter is that ocean acidification poses a serious threat to the survival of king crabs. An experiment conducted by the University of Hawaii showed that in seawater with a pH decrease of 0.3 units, the mortality rate of juvenile king crabs increased by 40%. What is even more worrying is that an acidic environment can affect the formation of their exoskeletons, making crabs more vulnerable to predator attacks. Climate change has also brought another unexpected impact, the spread of parasites and diseases. In 2018, a large-scale outbreak of crab parasitic infections occurred in the Gulf of Alaska, resulting in a 30% decrease in the local king crab population. Scientists have discovered that rising water temperatures enable these parasites to survive and reproduce in new areas. The expert report of the Arctic Council states that climate change and species invasion are forming a synergistic effect, accelerating changes in the Arctic ecosystem. The emperor crab is both a beneficiary and a promoter of this change. This complex interaction makes prediction and management more difficult. Innovation in technology and management. Faced with the challenges brought by the king crab, scientists and managers are developing innovative solutions. In terms of monitoring technology, the combination of autonomous underwater robots and environmental DNA technology make large-scale and efficient population monitoring possible. A new monitoring system developed by the Norwegian Institute of Marine Research. It can complete a survey of 100 square nautical miles within 24 hours with an accuracy of over 90%. In terms of management strategies, ecosystem-based management methods are replacing traditional single-species management. This method considers the state of the entire ecosystem, not just the population size of the target species. The new management plan adopted by Alaska includes 18 ecological indicators, ranging from benthic biodiversity to carbon flux, to comprehensively assess the ecological impact of king crabs. Genetic tools also provide a new perspective for management. The study on the genetic structure of the king crab population found significant differences in populations from different regions. These pieces of information help managers develop more refined management strategies. For example, establishing genetic diversity conservation areas to protect unique local populations. Market mechanisms are also playing a role. The Sustainable Certification Program of the Ocean Management Committee provide market premium for emperor crab fisheries that meet standards. At present, the Norwegian Bering Sea king crab fishery has obtained MSC certification. The price is 20% higher than ordinary products. This economic incentive encourages more fisheries to improve management practices. Future prospects, between utilization and protection. Looking ahead to the future, the global story of emperor crab continues to be written. Climate models predict that in the next 30 years, the king crab may further spread southward. Enter more waters in the North Atlantic. Meanwhile, with the opening of the Arctic shipping route, human activities may inadvertently help the king crab overcome new geographical barriers. Scientists suggest taking preventive management measures. This includes establishing an early warning system. Take timely action when discovering king crabs in new areas. Develop more accurate population models to predict population dynamics. Strengthen international cooperation, share data and experience. The Arctic Council is promoting the establishment of a regional framework for the management of king crabs. Coordinate the management and research efforts of all parties involved. Technological innovation also provides new possibilities. Genetic technology may help scientists understand the mechanisms by which king crabs adapt to new environments. Artificial cultivation technology may provide support for protecting native populations. Although fully artificial farming still faces challenges. But it has shown potential in resource enhancement and population recovery. The most important thing is that we need to change our way of thinking about ocean resource management. As the renowned oceanographer Sylvia Earle said, "We can no longer view the ocean as an inexhaustible resource pool. Each species plays a specific role in the ecosystem. Our intervention must be based on an understanding of this complexity." The global story of the king crab goes beyond a simple narrative of ecological invasion. They are a vivid symbol of the Anthropocene era. In this geological era, human activities have become the core force in changing the global ecosystem. From Soviet laboratories to stormy waters in Alaska, from fjords in Norway to deep waters in Antarctica. The footprints of the king crab record human ambition, negligence, and wisdom. In this complex story, we see the ambition of humanity. During the Cold War, the Soviet Union demonstrated the superiority of socialism. Not willing to interfere with nature, introducing the king crab into new waters, hoping to create enormous economic value. This desire to transform nature reflects the conquering mentality of humans towards nature during the industrial civilization period. Believing that humans can control nature and serve themselves through science and technology. However, the complexity of nature far exceeds human imagination. A seemingly simple ecological experiment ultimately led to unforeseeable ecological consequences. We also see human negligence. In the early stages of the emperor crab transplantation experiment, scientists had already discovered signs of a decline in the number of benthic organisms. But these warnings did not receive enough attention. Decision-makers focus more on economic benefits and overlook ecological impacts. Scientists have insufficient understanding of the biological characteristics and ecological adaptability of king crabs. Insufficient prediction of their dispersal and ecological destructive power. This negligence has led to the global spread of king crabs, causing a heavy blow to polar marine ecosystems. But at the same time, we also see the wisdom of humanity. Faced with the challenges brought by the king crab, scientists and managers did not sit idly by. But through technological progress and management innovation, seeking solutions. From advanced monitoring technology to ecosystem-based management strategies. From the application of genetic tools to the guidance of market mechanisms. Humanity is using wisdom to make up for past mistakes and striving to achieve a balance between ecological protection and economic utilization. The ability to learn from mistakes and constantly adjust is the key to humanity's response to the global ecological crisis. In this complex story, we also see an interconnected world. How a decision made during the Cold War will affect global marine ecology decades later. How a region's fisheries management decision affects the global seafood market. How a country's carbon emissions can change the ecosystem of polar oceans. The story of emperor crab tells us that in the era of globalization, the Earth is an interdependent whole, and any local action can have a global impact. The future of the emperor crab, to a large extent, will also foreshadow our own future. Their response to climate change, their interaction with human activities. Their changes to the ecosystem are reminding us that on this human-dominated planet, every choice has global consequences. We can no longer view the issues of a certain region or species in isolation. We need to take a global perspective and take coordinated actions to jointly protect our blue planet. When we enjoy delicious crab legs in a high-end restaurant, perhaps we should remember. Underneath this red armor lies a profound story about global connectivity, ecological balance, and human responsibility. In this story, each of us is a participant and also an author. And the chapter we write today will determine the ultimate outcome of this story. Today, as glaciers accelerate melting and seawater continues to warm, the journey of the king crab continues. Their fate is closely linked to human choices, weaving together the most complex and important ecological narrative of this era. This narrative is not only about the rise and fall of a species. It's more about how we understand our position and responsibility on this planet. Only when we truly realize that humans and nature are a community of life. Respecting nature, conforming to nature, and protecting nature are the key to long-term survival and development on this planet. Only then can this story about the king crab have a harmonious and beautiful ending.